Hey, section 10.8, graphs of polar equations. So of course, if you can have polar coordinates, you get enough of them together on the same graph, connect the dots, like when kids love to do, and you can create graphs of these polar equations. So in this section, we're going to look at a couple of those examples. So we have r equals 4 sine of theta. So the radius will be a function of theta or angle values. So theta is our input, r will be our outputs. So using 4 sine theta, plugging in 0, sine 0 is 0 times 4, you get 0. Pi over 6, sine of pi over 6 is 1/2 times 4 is 2. Pi over 3, sine of pi over 3 is root 3 over 2 times 4, 2 root 3. And because I'm feeling lazy, 2 root 3 is the decimal, but 3.46. Gonna put that there for now. Pi over 2, sine of pi over 2 is 1 times 4 is 4. 2 pi over 3, that's again root 3 over 2 times 4. 2 root 3, or about 3.46. Because graphing radical values is kind of not difficult, not hard, it's just annoying. So decimals are going to be better for graphing quickly. 5 pi over 6, that's 1/2 times 4 is 2. And sine of pi is 0 times 4 is 0. 7 pi over 6, see sine of 7 pi over 6, that's negative 1/2 times 2, or times 4, negative 2. 3 pi over 2, so sine of 3 pi over 2 is negative 1 times 4, negative 4. Kind of skipping more around the unit circle here. So 11 pi over 6 is again negative 1/2 times 4, negative 2. 2 pi, the same as 0, be 0. So let's graph these. Let's see. At theta 0, r is 0, so right to the origin. At pi over 6, going 2 towards pi over 6. So 2 circles towards pi over 6 right there. Pi over 3 is 3.46. So pi over 3, 3.41 to 3 points, about 3.5 right there. Pi over 2 is 4, 1, 2, 3, 4 right here. 2 pi over 3, so 2 pi over 3 is again about 3.5. 2 pi over 3, about 3.5, 3.46. 5 pi over 6 is going to be 2, so 2 circles towards 5 pi over 6. At pi, we're 0 again, so I'd have a dot there, alright. And now it's 7 pi over 6, so towards 7 pi over 6, I'm going 2 in the other direction. So towards 7 pi over 6, I'm gonna go 2 in the other direction. Hey, right towards the red dot I already have. Oh, you can't see that. Oh goodness, here we go. There, towards 7 pi over 6, go 2 in the negative, 2 in the other direction. See, 3 pi over 2, 3 pi over 2 down here, but going negative 4 towards that. So going 4 up, which I already have a dot right there at 4 comma pi over 2. 11 pi over 6, negative 2, I'd have that dot right here. 2 pi 0. So let's connect the dots. Now I'll try to draw a good circle here. Look at that gray circle. I'm so good at everything. Okay. So, you see some of those points were repeated, and that would happen. As you go through the whole unit circle, points can get repeated. You just draw them once. You don't need to draw them again. Sketch the graph of r equals 3 plus 2 cosine theta. So let's look at this one, okay? At 0, cosine of 0 is 1, times 2 is 2, plus 3, that's 5. Oh no, I'm still on the tool there. There we go, 5. Pi over 3. Cosine of pi over 3 is 1/2, times 2 is 1, plus 3 is 4. Pi over 2. Cosine of pi over 2 is 0, times 2 is 0, plus 3 is 3. 2 pi over 3. Cosine of 2 pi over 3, that is negative 1/2 times 2 negative 1 plus 3 is 2. Cosine of pi, negative 1 times 2 negative 2 plus 3 is 1. 5, 4, 3, 2, 1. Let's see what happens. Okay. 0 at 5, so 1, 2, 3, 4. Whoa, 1, 2, 3, 4, so way out there. Okay. Pi over 3 is 4, so 1 in. Pi over 2 is 3, so 1 circle in. 2 pi over 3 is 1 circle in. Believe that's it? Okay. And pi is 1. Now remember, x equals cosine of theta, right? So cosine graphs have horizontal symmetry. So whatever is above the polar axis, or the x-axis, whatever is above the horizontal, will get reflected below the horizontal also. So at 5 pi over 3, have a 4, 3 pi over 2, be 3, 4 pi over 3 will be 2, and then pi is 1. And if we connect this, I'll do my best. Okay. That's what I got. Okay. So what we have is kind of a dented circular shape. This is called a limacon. Oh, forgot the A. Limacon. Limacon. Try that again. Limacon. So, to get the limacon from a cosine graph, you only need half the graph. Anything above the polar axis. Conversely, y is sine of theta from the unit circle. So sine graphs have vertical symmetry. And anything to one side of the vertical axis, the pi over 2, 3 pi over 2 line, can be reflected to the other side. Look here at this graph. you see the circle is half on one side, half on the other. Okay, so using symmetry, maximum R values, that the values they give you 0, they can speed up the graphing process, okay? So on the next page, kind of look at these also. I don't know why those are there. Tables of values. It might be helpful, may not, who knows. But check out those examples and have 3 more at the bottom for you to try also. And then check your work with my complete notes online.